Worked this weekend a lot to bring my little server into a state of good being, and then I made some slides to try to well, it's a good decompression technique, and you want to collect your thoughts. And so I'm going to present this, what's going on technically. I'll be uploading this video to a channel I'm going to make so that the tool has its own channel, because I'm going to do something where you can go to the tool, upload a video, and it uploads it to YouTube, to the shared channel. I think that's how I'm going to start with whatever I do in terms of, I have some, well, we'll talk about other people using this. It's really a tool I'm making for myself, but in terms of starting something we could all share, I was thinking I'd make it so you could go there, upload a video, and maybe we vote on which one goes to the video channel, or maybe we just are talking about the video channel idea, they automatically go or something like that. But that's not really what this video is about. Okay, so the idea I have here is for a distributed system. Let's call it a distributed video bank for now. And this is a mini report from the Code Lab, episode 1. Okay, so I warn you, this is a technical talk. Here's the technologies, a list of main technologies that I brain dumped last night. So it's all open source. I'm running on Ubuntu 12.04, which is a form of Linux, which is a form of Unix. You either already know more than that, or that's all you need to know, I guess. It's an operating system instead of Windows. I'm using Apache 2 as the HTTP daemon, the server. When you connect to an HTTP colon something, you're going to an HTTP server somewhere. I'm using a very widely used one called Apache. I'm using a thing, mod WSGI for Apache, for running the Python to generate, using Python to generate the actual web pages that you go and see. And this is going to get very technical. I'm going to show you some of the source codes. I'm using a Python package called WebPy, which is a really lightweight system for request handling kind of tools, you know, to get the parameters from the request and stuff like that, templates, session management. Though mostly I'm using there's not much session management. I'm trying to make it stateless, but you do have to log in for certain things, so I'm using Apache Digest for that. I'm the only user. There's no way to sign up right now. I'm open to, if people want to try this out. Like I'm saying, I think I might open it to people that don't even have to register with this idea of the channel. But if somebody wants to, I'm making a little portal for myself in YouTube. If somebody wants to come and be involved with that, that's fine. And if somebody really wants to be involved, like they want to spend 20 bucks to have their own server and share images, and you know, their server gets maintained like mine, but they can customize it, be open to doing that in some short period. I think maybe Conference Report was interested in doing something like that. And before we got to that point, I'm willing to have 1 or 2 people just use this server of mine, upload it, and we'll try to get it. I want to see how many people for a $20 server can I support. You know, because it looks like you could have hundreds of streams simultaneously, but only, you know, 1,500 videos or something, so you have to share that space. But there's other ways to get space, cloud files and things like this, or just other storage anyway. Again, on a tangent, let's stick here. I'm using PIL, which is the Python imaging library, for image manipulation, like on that origami thing. I mean, that's how I crop the images. I also use it here because when I grab a thumbnail from the video, I like to make that thumbnail size. For converting the videos on the back end, I'm using something called libav, which is a fork of this old FFmpeg project. So you can upload pretty much any video. I mean, I've just uploaded the videos like I'd normally upload to YouTube. They go into this system. The system's able to output a video of another format, and I'm using WebM because it's totally uninfringed by patents, and at whatever resolution you want. Eventually, if other people are using this, I'd let them set their resolution. You'd have maximum storage limits, and it'd be up to you. If you want high-def videos, you could have them. You could even just leave them in the regular definition as you uploaded them, but I do want to convert them to WebM. This system is going to allow for tracking resources, and this is one of the things I did this weekend, is create the structure to be able to track the resource usages of individual users. So people can manage, like, I just want low quality video where the audio is audible enough and the video is visible enough, and I like that it's under a meg a minute. But if somebody wants to have high def, this system's going to allow for that kind of control of the use of the resources, and also giving that to people. It's like, you want an archive with 3,000 videos? Well, it might cost you 10 cents a month. Okay, I wrote this weekend, I wrote a back-end server. I'm calling it the Capta server because this is going to be an RDBMS free. So there is data, but it's not a database proper like the standard. I've decided to leave the reservation. I'll talk about that in a second. I'm going to do my impressions of the state of software technology. But anyway, so I wrote a C++ server. It's good to be working in C++. It uses a thing called Mongoose, which is a lightweight embedded web server, because that's how it serves its information up. I'll show you that in a bit. Yeah, I use the Boost libraries for reading and writing JSON, because I'm letting all of the components, Python and otherwise, scripts, whatever, they can drop these little data files. Like the information file about a video just sits there in the same directory. And then this server, the C++ server, is able to see when that's created. It's able to discover it and load it into its database. And then it can keep a more optimized central database if it wants. It can keep indexing to the files. That's sort of its job. But it has to be there, because when people want to write these files, I can let a process write the file when, like, you upload a video and it writes, it knows it's the one creating that. But afterwards, like to say, oh, there's another view or something, you can't just let all these processes write, because they'll have race conditions and they'll write over each other and stuff. So this C++ process is taking the role of the RDBMS in that sense, that it's where you go to do write and read operations, and it also caches this stuff so you don't have to go back to disk. It's a web server in its own right, running on the back end as a daemon that the Apache processes, the Python scripting can talk to, and I'll show you what I'm talking about. Okay, then for the client technology, I'm relying on the HTML5 coming along, and it's not all there yet, but we have a video tag, and we have the WebM video format. We don't have the stuff that's coming that's going to be good, where you can stream straight from browser to browser, and you can make Stickum just a web page that would be able to do Stickum without a big server. The server wouldn't even really have to be involved at all. Just start the conversation. And I'm using a thing called jQuery for the Ajax and the browser UI. All right, I've been having a few revelations about computing, and studying for that interview that I totally hosed. I was just emotionally distraught. By the time I went over there, I didn't even care, and then they started asking me questions. I just went on a weird tangent. I was thinking more about other things, but I did think a lot about computing, and been reading some classic books again, and reevaluating some things. I think we're in some momentous times in terms of the web. I think that's potentially big for the world, but whatever. I'm not saying that. I'm just saying for the web it's big. This HTML5. Now I know, okay, yeah, point one, you have hype fatigue. I understand. So everybody's always telling you there's momentous times, but things change quickly. But I've seen some of these thresholds. Okay, HTML4 was a big relief in a lot of ways. But this is amazing, because things like right now, we have two things coming. One is there's HTML5, just the general, specifically HTML5, but the general idea behind it, and some things coming. You know, like things like the web wasn't really designed to play video, and people hacked together solutions for that. And really all these sites that do it, there's a lot of work just to make that work. Okay, but now with the HTML5, it's just a video tag. You put a video tag like an image, boom, that's it. There's no plugin, nothing. The browser knows how to play the video tag, and we're using that. That's available now. If you use the WebM format, any browser of any consequence can play it. The other thing is this cloud thing. I told a friend about the cloud. She's like, that's old. I've been using cloud on my phone forever. Look, those were cloud files and this concept cloud. But to me, we have OpenStack now, see, and this is an example of a real cloud. The idea with the cloud is that, okay, think of it this way. You know, if I wanted to give online concerts, and the Rolling Stones come to me and it's going to be a big concert, you know, to be prepared for that, traditionally I'd have to have basically $1 million server farm, right? I want to broadcast this. Well, now with the cloud, you don't have to, because see, here's what happened. The guy with the $1 million server farm's like, great, I got a bunch of investors, I can have that concert. So now I have a Rolling Stone concert. Now I wait 2 years for anything that big. And they have all this unused space. They have enough hardware to have a Rolling Stone concert 24/7, 7 days a week. And there aren't that many concerts. So they have a problem of too much extra resource they can't sell. Right? And I have a problem in that, well, I have to spend millions of dollars just to have the server farm in order to try to send a salesman out to say we could even do the concert. Okay, with the cloud, I can have my little $20 server. I can develop the software on it to do that kind of thing. I just don't have enough server resources. But I can rent a server for a day. You see, I could clone my $20 server. I could make 100 clones. Right? That's $2,000 a month worth of servers, right? But I can run them for one day and pay a couple $100. So it's more like renting a hall, you know, that might be a fancy hall, but just for a night, renting that, than having to buy the hall just to do a concert in it. So it's huge, okay? And it's important that it's the OpenStack, because like I did some of the stuff I've shown you guys has been on Google App Engine for the server technology. I like it, and it's cloud. It's distributed. You call it a cloud. Now the word cloud, by the way, just it's what we used to call the internet in general. All the computers are talking to each other. It's cloud, okay? Cloud's kind of semi, let's organize this, commoditize it. It's not quite a grid. We want to use the cloud as a grid, and well, so this word cloud. But what's really important here is that this open source aspect of it, because Google does this kind of distributed thing, and you do. All these sites have some sort of distributed thing. It's just that it's not all standards where it can be shared. So it's important that it be open source, whereas the Google, you're writing to their Google API. Right? Or if you use the Amazon one, you're writing to the Amazon API. And this, we have open source stuff, right? It's stuff I could run on my own hardware, not on the cloud. I could just get a machine, easily install Ubuntu 12, run everything exactly the same. Okay, so that's important. You can run it on a regular server. Okay, so let me tell you what the cloud really is in terms of this. And it's not, the storage part of the cloud is not, that's what we started to have a couple years ago, but it's this selling the CPU cycles in a way that I, as the programmer, can rely on, because that's the thing. It's like, I don't just want shared CPU cycles. I want a virtual machine where I really have one of the processors. It's really mine. I'm not getting interrupted to do something else because they oversold it. And so with the Linux, the way virtual servers work now, that's basically what you do get. Okay, so what I would say the cloud is, as I'm talking about it, not as a buzzword. I was talking to this friend, she's like, that's so hot. It's like, I could just talk about OpenStack or whatever. Okay, so the word cloud might distract some of you, being a stupid buzzword. But I always liked cloud, the original thing. I think it'll pass through this over-buzzed stage. And I mean, clouds are lovely. That's going to stand the test of time. Okay. But the one is the ability to move jobs basically to a grid that can execute the job, right? So I have a job that, let's say I have this video server and it can handle 20 people. Okay, I have the ability to just say, okay, well, I want 20 of those. And now suddenly I can handle 400 people, right? You have to be able to move the job easily. So the use of virtual servers allows this in an efficient way, right? Because I can have my little Ubuntu machine, and because it's a virtual server, this would be harder to do with a real server. I can just tell the computer that's running the virtual machine, take a snapshot of that, store it on disk, boom. And I can tell the subsystem that knows, that runs the virtual machines, it's like, hey, start 20 virtual machines with a copy of that now. And the copy has to be smart enough to wake them to go, I'm one of 20. I'm not the only one around. It knows how to know how to talk to each other. Then it joins together and can provide a website, which all the websites that you know that use are famous are provided this way by networks of computers. So this is known stuff. designing this way. And I've actually specialized. I've been working, when I was 13, I started writing bulletin boards and stuff. And anyway, it's a specialty, distributed design. And this is making that a really useful design approach, because you can really widely distribute your stuff. Okay, often, traditionally distributed design, you still have one server. Maybe you don't even need to distribute. You know, maybe it's stupid to distribute because they are on one machine anyway. Now they're really going to be on other machines. It's useful to distribute it, and I happen to think that's fun. Solving algorithms without central brute force nodes. That's what I'm into. I don't know if you could tell. I try to apply that in the real world as well as the computing. Okay. So basically, we're talking about making the computing resources fungible, if you know what that word is, and if not, you could look that up on the internet. The cloud is just a part. The idea of the cloud is part of Sun Microsystems. I don't know if it still is, but their motto was, "The network is the computer," and this is really what a lot of us that were into the phone communication with computers from the way back. It's like this is almost spiritual or religious movement. The network is the computer. The cloud, therefore, is the network with all the computers on it. And it's not just the stuff that holds it together, it's the whole network, including the resources of the computer itself. And that is the computer, right? And so I'm going to use open source to the optimum and in-house for the rest, I think. But, you know, I'm not saying I'm against ever paying for tools, Adobe Photoshop, but I don't pay for that anymore. I used GIMP for years, but, you know, it is a special tool. Some people, professional artists, probably need tools like that. So I'm not saying that, but on the server and stuff, and we're definitely keeping everything out. It's going to be very open source. So you'll be able to set up one of these yourself from instructions. Or with my Rackspace account, if people want to set these up and expand the network, I'll just be able to say, okay, click, 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 you got one. And I can let you log in, or maybe you won't want to log in, and I'll do that level of, I don't know, I haven't figured that out, but I can just go clone another one. And so that's important to have open source to be able to do that. Okay, one thing is, I'm thinking, I had some negative dreams, not really literally, but metaphorically, about the relational databases. I think it's kind of a kludge and crutch, and it's on its way out. And if you're knowledgeable about computer architecture, especially modern mission-critical systems, then you'll deny that that makes sense, that relational databases are on the way out. They dominate more than COBOL in 1975. Hope I chose a good word for year for that example. But that's what I think. You know, places like Google and the really cutting edge with huge amounts of terabytes and terabytes of data, you don't use a relational database. You're better off organizing the data. However, basically, it's always more efficient, except for if you have a query you didn't anticipate. Relational databases give you a constant time, but they slow down things that you know you're going to do a lot, and you know ahead of time. And to design your database well, you really design your tables with that in mind. So why not just keep them in memory in the form the program wants them, right? The program has to ask for it from a database, and it brings it in, then it has to assemble in its own memory in a certain way. Why not just keep it in that order? You could dump that to disk and read it in faster than you can make a query, which is looking all over a bunch, you know, files. Okay. And the reason is that, well, you get it in this tree, say index by these values, but what if you want to index by some little value that's down here and reorganize it? It could be hard with that tree in that form, but if you anticipate those things and you're willing to do background process to reorganize and reindex things when you do invent a new way you want to look at the data, in other words, you don't just have to support looking at the data whatever way at whatever time, but you know, with some planning, then I think you're better off without a relational database. So that's why I've written this thing, this process JCN, that's doing the database thing. It's keeping the video index and stuff, and I'll show you. It's communicating with JSON, and I definitely can develop with it much more rapidly. I don't have to make so many rigid decisions about what kind of tables I'm going to have. And I don't have to even have tables. I can have arbitrary information stored. Plus I can support a multi-tiered model where the first model is a lot of the web server is able just to drop files and it's in the file system. Then this guy, instead of ignoring the file system and putting it all in a table, I can make a program that's smart enough to pay attention to little fragments of data in the file system and still put it in a binary, well-indexed file using all of, you know, the advances that they, for example, use in relational databases to make that a high-speed, well-organized filing system. And it can be done better because we know the semantics of the data when we're making those decisions. Of course, you're still going to want to export information into relational database so that data analysts can do these purely arbitrary, hey, I want to know how many people with the last, you know, names that have the third letter L do this and that, you know, so you still, but you're going to be exporting it, not using it to generate the site. And I'm already seeing very much faster response times because I'm doing this. Okay. And then the HTML5, the video playing is here, video capture is near. You can kind of already do it a little bit already, but not really, and the spec isn't done, but the browsers are on it. A client-based video chat, right? You come to my web page and it just shows you the IPs of the other browsers and you can make a phone call, and then it doesn't even use my, you can just do it from a from a blog page because the browsers would contact each other and do a stick'em thing. That's gonna be cool. That's in the next couple of years. These quicker, really, but I mean on all the browsers, a couple of years. It's so we've waited forever. Okay, it's happening. WebSockets. Right now, if you want your web page to act like it's like monitoring something, how much of this is done, it has to ask like every second, every half second. That's a very inefficient and bad thing to do. With WebSockets, it could just say, okay, I uploaded this. I open a WebSocket to status on how much it's been processed. And then the server can just send information when there is information instead of this thing. Millions of them going, oh, what, right? So WebSockets, awesome. Okay, they're sort of here, but I wouldn't be really using them. With all of this with no plugins, no patents. All right. So I also noticed that the current video server solutions, the Vimeos and everything, and the softwares like ClickBucket, they're all invested in this old way of doing things where we needed our Flash plugins and stuff. So with all this stuff built around that, they're going to support HTML5 as just another way of doing the videos. And they're going to have to fit it into their old crufted way of doing it that they had to do, and they're going to say, look, we learned how to do multiple browsers and multiple video types, and so we could support all the browsers and all that complexity, and this is just one more that they all support, but you don't need to do that. You can just use the new one because everybody supports it, and then convert file formats to get to that, and everybody can use it. So I thought it was better, so I deleted all the ClickBucket, media, core, you know, media management stuff. And I'm just gonna make one. We can add tools like that back, but okay. So let's look at how my server is architected. There's your HTML5 browser. That's your browser. That's your IE, or well, it shouldn't be IE because it's not gonna work. Talks to an HTTP server, which hosts a bunch of static files, and also a Python framework that creates the web pages. And then that hexagon is what I'm calling the captive server. It's a distributed system, so I've got two components in there. One is the JCN daemon, which is the C++ daemon I'm talking about. I'll show you in a bit about it. And then that arrow thing is, I might change all these names, but you have to have a name to put on slides. But the morsel language, where I have these little database fragments that can be collected in a binary table, a process can know them, or they could be little files on the disk, right? So the real database is distributed all over just by nature, and then little bits of those bits are all collated and indexed by processes that want to say, for example, well, I want to know what all the videos are. So the JCN actually watches the video ingestion directory. Every time one comes, it loads it up. If I kill it and it has to start, then it has to reload all of that. Right now it goes through the disk and gets that. But obviously, as soon as I want, I will cache that information, and it'll only go through and see if there's things that fell through the cracks sometimes. And everybody goes to the JCN to get that information, so I can refactor how that does it. Okay, and I have to be careful what processes write and read and how they read, but that's my job. Okay. And then you have this video store where the actual files are kept, the uploads. There's a transfer in, and then it stays in there in its native format. That'll be purged at some point, but right now I only manually purge it. And then there's an ingested video area that's separated by usernames, and that's something I did this weekend. Made it so it's separated by usernames. And I wanted to do that because if I have somebody help me use this as a YouTube portal and kind of make the stuff, then I just had a stray thought of something I wanted to say. Then this will be an easy way to see how much storage people are using if I put all the videos in one directory, being more of a pain. So I got to do that stuff right as we go, and it's all running on the Ubuntu 12.04. So I just remember what I'm going to do with my channel. I realized last night, I'm just going to make it we can upload videos. It's not so much of voting on it. I'm going to make a voting app that when you see something you like in the video, you just say, I like it. And if you don't, you say you don't like it. You know, and maybe there'll be more than one kind of pair. Maybe it's smart, it's not smart. It's factual, it's not. It's informative, it's uninformative. And so while you're watching video, you can click this. And then we'll make those charts about who liked what. And because I can make that tool really quickly, I realize. So, okay. Anyway. Alright, so that's a little picture of the server right now. Okay, and what you have back here is the Python is communicating with the Capta server with HTTP in the back end. It's communicating with the video store through the file system. The browser is using HTTP to talk to Apache, and you can stream a file more or less straight if you want. But if you, for example, go to my video viewer, you're basically coming into this Python web thing, which then gives you a video tag that has a link into the video store. Okay? Alright, so now the thing is, what we can do is this is designed for these things to be linked together. The Capta server through the JCN process and other processes I might make, or maybe I'll just expand JCN. I'm not sure how much. I'll make it a little group of processes and how big the JCN will get. Right now it's the communication node for the web interface, because there's already multiple of those. Apache likes to run 5 processes, for example. You can run as many as you want. So those are all going to be talking to each other, and those front ends are going to be going to their local JCN and finding out what's going on in the whole network, right? Now on the cloud, these things don't have to be bundled with their machine. That's the point. I could run this JCN, these different shapes. I could run Apache on a whole different machine than this JCN and whatnot. You know, right now the way it's designed, it needs access to the file system. But in general, I mean, it doesn't in general. So in the long run, we don't visualize it all on the same machine. Instead, we look at the component on the web. These Capta servers are all fitting together to make one big server seamlessly. The data stores are all out there wherever they are. It doesn't really matter. The browser is the one that ends up having a pointer into them. The Capta server just tells you what data store through a web URL. It just tells you here's where the video is so that you can play it in whatever kind of player you're using. Right? And then this is all accessed by browsers all over the internet that make up the actual internet on which this is all constructed. Though I did think having it behind didn't make sense with the Z layering. So really it's more like the internet is all the people, all the browsers out there, front and behind, and embedding this kind of a cloud server behind there. I really like that kind of picture. Okay. So now let's just do a short video, a couple videos. So I recorded them all, but I'll just tell you here, and then we'll insert the video. Okay, this one, one of them is I'll just show you the upload form and the list, and the video list and the video viewer, and then I'll show you source code from each of those. And then, what was the other thing? I went through 3 things, I thought. Oh yeah, I also log in with SSH and show running the JCN by hand and starting it as a service and stuff. Okay. Alright, so I'm going to edit all this together and it'll be ready in a minute. It won't even seem like you had to wait because of course you're not watching till later. So I don't know why you're complaining. Okay, stop. Now. Alright, so here's the video list that as the user sees it. You can see over here a little not logged in. I can upload things, probably ask to log in. And this is the video list. So if I go to upload, now I'm going to log it in. If this was wider, that this would be to the side. I don't really want to do that part. But once you log in, there you go. You look like that. To view the video, and so on. This edit doesn't work right now, actually. Direct link, the description. Oh, I know I had a better one with a better description. This one. Better description. See what happens when you make it really small. Oh, interesting. Okay. Yeah, I made this scale and proportion. Video list. Okay, very minimalistic. Functional. Okay, finally. Alright, so this is an editor looking at the code. This is some of the Python code, but first let's look at the video view now. So, no, video list. So this is a template in WebPy. Likes to start off with that, right? And this is just an argument to this template. And then you can write HTML. This means that you can have Python code, that's a line of Python. It could be done more tersely. This actually means that the page can output titles, so then this template outputs a title and that can be embedded elsewhere in another template. I believe still in using tables. So this is interesting here. So in that video list that the user sees, this for loop generates through this Python object that has a bunch of videos, right, that the video catalog knows about. Gets it from the C++ server, which I'm just calling the captive server at the moment to not confuse it with a relational database. And then you have this HTML in here. It's indented as the body of this. It's pretty convenient. This is jQuery here. Gotta have $2 signs because you use the $sign to put in code. So yeah, this is a templating system. So it's HTML, but it's really mixed. Alright, here is C++ code. So this is the code I have that monitors the video ingestion directory. The main program calls monitor uploads with the monitor path and a pointer to the video cat. This is in C++ now. Object, video catalog, adds an iNotify watch on all of the following. Here's where it's adding the video. Here's the main program. It's doing the simple requests. And okay, so this is where we started with the I had up there. We didn't talk about it. I didn't talk about it, but it's the still have a lot of the code in the main application, the WSGI, which is actually a Python file. And here's where I'm handling templates, and here's where I'm handling the origami handling. Here's the uploading videos. Down here's uploading images, and so on. And okay. Oh, I wasn't going to say where it's made sure. Okay, finally here is so this is me looking for JCN. Here it is. I made it a service, so what am I thinking? Sorry. It's getting a little late now. It's only 11:37, but I've been staying up too late. It's always good to do your password a couple times. Okay, now I'm just going to show you what it does. See, so it's loading the videos that I noticed about, which is just those 3. So over here, this is what the JCN is sending over here. This web page goes to that server. The server on the back end, Apache, running a Python script, talks to this server and gets this actual information, uses what it needs to produce this, and send it back to the client. Okay.